Okay. I don't know. I might tear up here. We'll see. This is it right here. The last new concept in geometry. Yep. I'm devastated. Last new concept I get to teach you in geometry. Obviously, we feel the same way about it, so perfect. Okay, perfect. Which means this weekend's homework's the last homework grade, and that's it. All right, then you have your test, and then we start reviewing for the regents. All right, let's go. Here we go. Should I be in the last, being the last class, I get to teach something new. Some of you are already annoyed by me, and this same thing goes both ways. Don't worry. We can just do class this whole way right here. Do it that way. Or I can just every once in a while pull that out, right? So just in case some of you guys get a little tired, a little cranky, all right, here we go. All right, similar solids. Don't write any of this down yet. Do you remember last unit when we did this right here? The similarity ratio was always the same ratio as, anybody remember? If I knew this was 3 over 4, what else was 3 over 4? Perimeters, yep. And then anybody remember what I had to do to go from similarity to area? Square it. We're going to do the same thing today except for surface area and volume. And I'm thinking you guys can know what to do now for surface area and for volume. All right. So before we get there, similar solids. There's 2 things for a similar solid. They have to be the same shape. I can't have a sphere and a cylinder be similar. It's not going to happen. They got to be the same shape. And the second thing that has to happen, corresponding parts need to be in the same ratio. Right? So they both have to be the same solid. And so I'm talking, when I say corresponding parts here, hey, the heights, the widths, 2 radii, 2 heights are all in the same ratio. All right? All right, so take a look at one. What first of all, are those the same solids, number 1? Are they both rectangular prisms? Done. Okay, now what I need to test is, are the corresponding parts in the same ratio? So give me 2 that match up. 14, give me 2 dimensions that match up right here. Okay, so does 14 over 8, is that in the same ratio as? Give me another 2 matching dimensions. 5, 2 other matching dimensions. Does that equal 7 over 4? And hey, 2 doesn't cut it. 2 does not cut it. It's got to be all 3 in this case. So the final matching dimension, 10.5 over 6. Can we figure out if all those are in the same ratio? And how are you doing it? How do I figure out if all 3 are in the same ratio? Divide them. See if they come out to be the same decimal. And what are you noticing? 1.75, 1.75, 1.75. So these are similar. But hold on, anybody want to read the directions? If they are, give me the ratio. So what's my similarity ratio? You go a lot of different ways here. Just give me a ratio of 2 corresponding sides. Anything. 5 again. Here we go. Ratio of any 2 corresponding sides. What's up? 7 to 4. Yep. Could I have done 14 to 8? Could I have done 10.5 over 6? 1.75 over 1. Yep. Guess I do need to go to this just to talk over some of you. I don't want to interrupt any of your conversations back there. Sorry. We good? Everyone all right? Ready to go? It only gets more annoying back there. Trust me. All right. Good? Okay. Love it. Love it. How about these cylinders? Similar or not? Well, they're both cylinders. Give me a corresponding dimension for me here. 13, pair of corresponding dimensions. There you go. Does 12 over, what was it? 9 equal 9 over 5. Equal ratios? 8 equal ratios? Got me. 21 equal ratios? Nope. So we're going to say those are not similar. All right, here we go. I think you guys could be able to do this on your own here. If you know the similarity ratio, how do I get to the surface area? Surface area. Surface area. So if I know this side, if I know the similarity ratio, the ratio of two dimensions, they're not equal. They're not equal. Surface area. Somebody adjust that proportion for me. Square it. Square them. Then they'll be equal to each other. And how do you think it works for volume? What do I need to do to it? What do I do to this ratio? Cube it. Cube them. Yeah. All right, let's keep trucking. Maybe we'll have some time to work on the assignment. They're similar. I gave you the surface areas. Here's what I need, guys. I need the similarity ratio. What's the ratio of two corresponding parts? Going backwards now. Going backwards. What do you think? What do I have to do with 49 and 81 to get to the similarity ratio? Thoughts? Let's go 20. Thoughts? Yeah, darn right I do. So this will be equal to the square root. Oh, hold on. Find it to the smaller to the larger. Okay. So order does matter here. (26) your similarity ratio. Yep. That means the heights are in a ratio of 7 to 9. Your radii are in a ratio of 7 to 9. Okay, what if you're given volume, though? Volume, and I need to know the side ratio now. We have done this in this unit. What do you think I'm going to end up doing here? 28? Nope. How about 14? What do you think I have to do to the volumes here? Cube, not cube it. Cubing it would be this, right? Cube root it. Yep. Hey, could somebody teach me up here? Let's say I was absent that day. Where do I go on my calculator? Math button. Some of you can go to alpha window. All right, but all of us can go to math and see choice for me, choice 4. And then I can take the cube root of anything you need. So the side ratio for this one, here you go, 4, side ratio. 5/8. Any issues yet? Because this is where it's going to get pretty tough, 5 and 6. All right, go ahead, just read through it. Okay, everyone see what they're saying. I'm giving you the surface area of two figures, the volume of one of them. What's the volume of the other one? What are we looking for again? Volume, which means you need, if you want to set up a proportion, take a look. If you want to set up a proportion, you're going to need to know the volume ratio. Okay? What ratio do you know in this problem already? Surface area. So here's where we need to start thinking here a little bit. You got surface area. How do I get to volume? Because there's no conversion to go from surface area to volume. I didn't give that to you. All right, there's none up here that says to go from surface area to volume. So I need your help here. Can you get me, if I know surface area is equal to 75 over 108, can you guys get me a way to get to the volume ratio? Is there a way to get there for me? Think about it. Think about what we've just did here. Can you get me to the volume ratio so I can set up my proportion? What do you got, Thomas? Thoughts? I'm sorry. Just go ahead. That was rude. Sorry. Okay. Oh, right. By what's that going to give me? By square, not the volume, but by square rooting, what's it going to give me? The similarity ratio, right? All right. So let's start there. I got you. So let's take the square root of both sides. So square root of 75 over the square root of 108. Please leave it as a fraction. What are we getting as a fraction there? Change it to a fraction. Hit your math button. Change it to a fraction. It's a big fraction. Hopefully it's not that big. 5 over. And then done it? Taking the square root, you mean? Well, if you simplify this, Paul, it's still the surface area. You didn't change anything yet. You can simplify it, then square root. It's still going to come out to be your similarity. But yeah, simplifying it won't change it. So what are you guys getting? 5 over 6? Remember, that's your similarity ratio. Now, keep building off of Thomas's explanation. What do I do to this similarity ratio, 5 over 6, to get to the volume? Cube it. There you go, everybody. Cube it. 5 to the third, 6 to the third. What is your volume ratio now? Volume ratio? 125 over 216. Now we can set up a proportion to solve for the missing volume. Now that you know the ratio is 120, here we go. Now that I know the ratio, not like I'm trying to teach or anything. 125 over 216. There's the ratio. What volume did I give you? 216, is that the smaller or the larger one? Read the directions. Larger, all right, so I should put it across from the other 216, right? You can cross multiply if you want. Some of you probably see what the other volume is going to be. The other volume? 125. What units do we have here? Cubic centimeters. If you need to find the volume, you got to find the volume ratio. If you need to find surface area, you need the surface area ratio. I'm going to walk around and watch you do this next one. Yes? Well, that was the top number. Pure coincidence. It will not happen here. That's why we have you do a second one. Yes, it will not happen here. $256 cubic inches. Yes, Emma, go ahead. What are we looking for? Volume. Our volume and similarity. in the same ratio? Which is what we did, right? Oh, what are you saying? Could you go 4 cubed over 5 cubed equals x over 500? Yeah, absolutely. Yeah, that's fine. Yeah, that's fine. You don't have to do like 64 because 4 cubed is, what's that? 4 over 5 isn't equal to 64 over 125. If you do 64 over 125 in your calculator and get it back to a fraction, it won't be 4 over 5. Try it. Yeah, it won't be. It does, this right here doesn't reduce down to 4 to 5. Okay. All right, here it is. I don't know. You want a moment of silence? The final problem together. Who cares? That's all stuff we've done. So this is it right here. Wow, for some of you, it's a year and a half, huh? Worth of stuff. Wow, I'm tearing up for you guys. Good times back then, tearing up. All right, well, we got a block of ice. That's just how we're going to end it, with just a block of ice, plain block of ice. Weighs 2 pounds, everybody. Great. I am going to double each dimension. How much does the new block weigh? Oh, 4. I doubled it. Good try. Good try. Good try, though. Yep, good job. All right, well, we got a block of ice. I might as well do some diagrams, right? Look at that thing. Yeah. Here you go. Has nothing to do with what I'm about to set up, but here you go. 2 blocks of ice, trying to make it visually. Can I color it? Here you go. Can I color it in? Oh, but just ruined it. What's the issue with that one? There it is. Look at that. Yep, it's perfect. Yep. All right, calm it down. Calm it down. Yep. That's great. I know. The people watching this right now that aren't here and have to get the notes, they're like, all right, what? Come on. This is just wasting my time right now. Hit the fast forward button. Okay, this one weighs 2 pounds. We're trying to find out how much this one weighs. Okay. When we talk about weight, we are talking about volume. All right, the weight, the mass inside here. So this is going to be volume. Can anybody tell me about the ratio of their sides? Anybody know? They're in the same ratio? It's all right. What do we know about them? What do you know? What can you tell me about the ratio of 2 corresponding sides here based on the problem? Like if this is 4, what's this? If that's 4, this will be 8. If this is 5, that'll be 10. So what are the ratio of the sides in? 1 to 2, 2 to 1, whatever order you want to put it in, right? And what's the weight of the smaller one? Okay. So I'll put a 2 here across from the smaller number in the ratio. And we're trying to find the weight of the bigger one. Well, you just said it wasn't 4. Well, it's not. We still have to do something to that proportion. Similarity and volume don't equal each other. What do I need to do to my similarity so the volumes are equal? I need to cube my similarity ratio. And you'll see it's much more than just double the weight. So that 2-pound block of ice just became how many pounds? Yeah, 16 pounds. 8 times the weight. 8 times, and why 8 times the weight? Because we're cubing things. So 2 cubed is 8. So it should be 8 times the weight. All right. Any questions there? Go ahead, grab a textbook in the back or a Chromebook. Also, I don't know, I haven't looked at my list from the first day of school, but if you have textbooks that you borrowed, you could start bringing them in next week because this is the last assignment you need out of the textbook. Okay, so if you borrowed one, you can start bringing them in starting next week. All right, let's get going, please. We're focused on the math, please. I don't want to come around and see a Chromebook opened on something else.